Welcome to Building the Future, hosted by Kevin Horick. With millions of listeners a month, Building the Future has quickly become one of the fastest rising programs, with a focus on interviewing startups, entrepreneurs, investors, CEOs, and more. The radio and TV show airs in 15 markets across the globe, including Silicon Valley. For full showtimes, past episodes, or to sponsor the show, please visit buildingthefutureshow.com.
Welcome back to the show. Today we have Ethan Escowitz. He's the founder and CEO at Arris Composites. Ethan, welcome to the show.
Great to be here, Kevin. Thank you.
Yeah, I'm excited to have you on the show. I think what you guys are doing is really innovative and cool, but maybe before we get into all that, let's get to know you a little bit better and start off with where you grew up.
So, Northern Virginia, suburban DC.
Very cool. So you went to university. What did you take and why?
So I actually started in engineering and ended up with geology. And I gravitated towards the sciences through my time there. It was really kind of the empiricism, the exploration. I think I liked asking questions more than trying to solve for answers. And geology also has some really great field trips. So that's probably my entry exit. And the irony, obviously, is I've come back a lot more to the engineering world and don't do nearly as much with the geology world these days.
Interesting. Okay, so walk us through your career up until founding Arris Composites.
Sure. So I'd been in a number of roles in business development and research and development. I think I certainly represent one of those CEOs that's worn a lot of the different hats in the organization. Also doing operations. So a lot of my time, really prior to like 2008, had been more in conventional manufacturing technologies. But when I discovered 3D printing is where I really focused and have worked with plastics and composites and metal 3D printing technologies, as well as both the manufacturers, service providers, and even working with commercializing the technologies developed at the national lab. So really the last decade had been focused on the 3D printing world.
Interesting. So how did you come up with the idea for Arris Composites, and what exactly do you guys do?
Sure. So really the conventional manufacturing and the 3D printing that I just described were two really formative times in my career, and a lot of what we have developed represents significant elements of both of those realms combined into the technology that we developed. So to be very, very specific, we call our technology additive molding, and we take elements of the most advanced aligned continuous composite fiber technologies, but then we are also using elements of the molding world, which is the highest volume complex part production methods in the world. So you to kind of give examples of both spaces, in the composites world, when you look at like the Boeing Dreamliner, they're steering the composite fibers in very intentional ways to create the highest performance structures possible. And as you can imagine, the cost of those production methods are quite high and don't scale very well. But then you look, as an example out of the molding world, you go to any factory where they're have an automated molding cell producing parts extremely cost effectively that can have incredible levels of complexity and accuracy and repeatability and surface finish. So really we took elements of both of those worlds and combined them so we can get these incredibly high performance materials out of these very scalable automated manufacturing systems. So to really tie it all together, we enable the production of these parts that are that can be stronger than titanium at a much lower density. So you might be 1/3 the weight, and producing them cost effectively out of an automated manufacturing system.
Very cool. So can you maybe give us some industries or examples of how people have used what you have created?
Certainly. So with manufacturing, when you make a new tool, there are many different industries that can use that tool to make the products they produce better. So as a result, we've had very broad collaborations, and let me speak to that almost separately from looking at the idea that what we've focused on as a young company is the industries with a shorter product refresh cycle and lower qualification. So as you can imagine, you want to work with customers that can get you to revenue faster when you're a young company and you have venture investment. And then as you grow, you can take on broader industries and applications that may take longer to get to market. So for that reason, the first industry we focused on was consumer products because of the speed at which they can get to market. And we were very novel for consumer products because they haven't had the ability to use these really great materials to make differentiated products that give them a commercial edge in the marketplace. So there was a very strong pull from that market for our technology. So we can talk about that, but other industries we've worked with include aerospace and industrial. Aerospace in particular has been a leader in composites because of the very high price that is associated with weight when you're talking about aircraft and the fuel for aircraft. So in aerospace, in 1970, there was 0% composites in a commercial airliner. Today, the Boeing Dreamliner is approaching 80% composites. So this really illustrates the industry that's responsible for a lot of the R&D that we take advantage of, and we're kind of standing on the shoulders of giants there, but also an industry that has a big appetite for being able to make new parts that they haven't been able to make out of these incredible materials, which we have enabled.
Interesting. So if I'm an airline manufacturer, or a car manufacturer or whatever, how do I actually use your technology? Do you need to ship me like a printing machine? Do I have to send you the CAD renderings or whatever drawing format you need, and then you guys print them and ship them back to me? Or how does that process work?
Sure. So at present, we do all of the production ourselves directly.
Okay.
I've worked with a lot of companies in the past where we would launch 3D printers and send them out to customers. And ultimately, we have kept our production systems in-house longer than perhaps some new manufacturing technologies typically would, because when you're talking about higher volume production, the repeatability and reliability and scalability is paramount. So we have really put our systems through very rigorous refinement. And in addition, we take ultimate responsibility for that production. That said, we have in 2021 and beyond manufacturing partners that we will be working with, that we would ship production systems to, and could do some production for us, particularly different manufacturers that specialize in different industries where their expertise running our systems really would have significant synergy. And while we're working with some of those companies today, we will make the parts for them, and they will qualify them or work with their customers to qualify them.
Got you. So then,
so I should tie that back to
sure.
The simple summary is we produce the parts directly for our end customers today.
Okay, so then do you work with like their design and engineering team and say like, this is doable, that's not doable, like we try this, or how does that process or collaboration work between you guys and one of your clients?
Correct. So we have our applications development team is comprised of engineers of a variety of disciplines who have worked in this space. For instance, Simon Lancaster, who is our consumer products lead, worked over a decade at Apple, looking at new manufacturing technologies and finding ways to use new manufacturing technologies for commercial advantages. And so we have individuals like Simon and his team and others that take this professional experience and their knowledge of design for additive molding, which is our process, and work collaboratively with the mechanical design team, the antenna team, the various teams on the other side of the fence that would be adopting our technology and incorporating it into a product that they're developing.
Okay, no, that makes sense. So can you give us some examples of industries or things that have been directly created with your technology?
Sure. So we've made a variety of consumer electronic devices.
Okay.
A number of the existing common devices, as well as next generation wearables.
Okay.
Wearables are a particularly hot space for us because it's emerging. There are a lot of companies envisioning what's coming next. And as a result, those design cycles, are spinning quickly, and many people are thinking about how to make something really commercially compelling. And our ability to make many of the products smaller and lighter, and higher performance in a variety of different ways, whether it's antenna or thermal, gives them greater capabilities than they had to work with the conventional manufacturing technologies that many of them had started these processes with. So the consumer electronics has been one batch of customers we've worked with. Sporting goods has used carbon fiber composites broadly. So that space was already primed to our technology because of their knowledge of the material and the benefits. Our ability to make new shapes that were not possible, as well as higher performance composite parts than they've had before, has precipitated another group of opportunities, like in the bike industry, for example. But then also, we mentioned aerospace earlier. While the path to producing parts on commercial aircraft is a long one, with all of the qualification steps there are the drone industry is able to take advantage of all of the same methods and approaches, however, without the same level of qualification to produce, to move very quickly. And we will have had a neat press release with a customer that we worked with that was able to really innovate in their design as a result of our methods with a industrial drone that they developed and improved with our methods.
Interesting. So how did you guys actually come up with the technology and this material?
So we started in 2017, and at that point we had worked with both additive manufacturing as well as a variety of composite materials. So we work with existing raw materials. So that's the most important building block to start with. So we didn't create a fundamentally new chemistry. The thermoplastic composites that we work with are a very important piece of this story. Thermoplastics are really just amazing materials. They are the recyclable plastics. And the thermoplastic composites have been developed by Aerospace over the last few decades. So this is a new class of composites. Composites for many decades prior to that were just essentially like super glue or epoxy and not recyclable and more brittle. So the aerospace development efforts were getting these tougher, faster cycle time composites into the industry. So we're really standing on the shoulders of a lot of the research and development that was done in that industry, as well as around those material classes. So we worked with this material class of thermoplastic composites that you might have carbon fiber, or you might have glass fiber, or you can use other types of fibers, and you combine it with the thermoplastic, and you call that the matrix. So you might have, you just imagine like 50-50 matrix material, which is the thermoplastic resin system, and 50% glass fiber or carbon fiber, depending on the application. So what we did was we really looked at what are the shortcomings of this industry, what is missing. So in general, you typically are building with flat building blocks when you're making anything out of composites. Most people are familiar with, automotive body panels that are kind of 2.5D shapes. But when you are making anything complex, like a bracket or anything that has really 3D relief or complex shapes, they're typically machined. And in fact, they're 3D printing out of titanium many of the parts in aerospace, because you can't make those parts out of composite today. So what we did is we started with this material system, and we figured out a way to use this really mature material system and get the best out of it. Put it in these very important shapes. Many of them, a lot of work had been done in topology optimization, and really just having the best shape for the load or functional scenario that a part might encounter. And then most important, and what's really novel about our process, is within that shape, there's loading, and the way that you align the fibers should follow the loading paths within that 3D shape. And our process has the unique ability to essentially make these complex 3D shapes in a way that you can imagine resembles the way the grain of a tree works, where the grain follows the loading on the tree very much the same way that the fibers that we put in our part through our additive molding process follow the loading on that part. So what that enables is getting these really excellent materials that have been limited to fairly simple shapes, and allowing designers to put them in in a variety of shapes that haven't been possible before.
Interesting. Okay. So you guys had a press release recently. I think you just mentioned it before we covered that, but what exactly are they doing and how are they leveraging your technology in their product?
So the Skydio collaboration was neat and really illustrative in that they took advantage in a number of different ways of the capabilities we're talking about. So first is part consolidation. And I think most folks understand the benefit in reducing the bill of materials on any product. The less parts, the less suppliers, the less assembly steps, the less places there can be failure. There are many benefits to part consolidation. So when we took the original assembly of 17 components and made it one single one, there's a lot of benefits just simply in doing that. In addition, for a customer-facing part and a Class A surface, a surface that faces the customer, we're able to make it look really nice. But you look under the surface of this really good-looking designed part, and there's really advanced composite performance that hasn't been possible before. So first, with regard to material type, there's a antenna transparent glass fiber window. So this is a method that was developed in aerospace to allow antennas to work properly, that were, and you know, these are produced in very kind of in lower volumes, at higher costs with kind of artisan processes. Today in aerospace, we're able to do this with an automated production system just as part of our process. But a lot of those methods were originally pioneered in aerospace. So we have that antenna window, and then through the arms that are supporting a critical camera mount, there are these very, very nice topology optimized structures that are really just the ideal shape to support that load that enables the minimum amount of material for weight savings through those features. So all of that is done continuously, even though you have different types of materials within the same part. Everything looks really seamless and streamlined. So cosmetically, it looks nice, and then functionally, you have a single part, and then also the way that it was designed to handle the impact that might come from the product being dropped was something that was also factored into the part design. So this was a really great collaboration between our applications engineering team and their product development team to achieve an outcome that checks the boxes of a bunch of the different engineering stakeholders on their side.
Very cool. So how much lighter can you get this material compared to some of the traditional materials that you're basically replacing?
Yeah, so that particular part, I believe it was around 25%.
So quite a bit there.
It really, it depends. So the density difference, you might be 1/3 the density of titanium. Okay. So if we produce a part that is, exactly the same shape and size, you might expect to see something about 1/3 the weight. As it turns out, through design, you can frequently improve that even more. So it really becomes a bit of a case-by-case answer. But there was a paper just published by our CTO and one of our engineers in a composites publication. It was at CAMX that illustrated how we were able to, with an aerospace customer, save over 70% of the weight of a titanium 3D printed bracket, because we not only took advantage of the weight savings of our material, but by taking advantage of additional design latitudes as well that were available to us. So both material and design are two areas that we're typically looking at for opportunities to improve a replacement part.
Got you. No, that makes sense. Okay, very cool. So you guys recently secured a very big Series B round. Do you want to talk about some advice or what you guys, or why you guys decided to raise a Series B round? Because I think, like, I've raised money before in the past, and it is very difficult, even if somebody understands and is the industry and what they're in. But you guys were creating kind of a new material. And so can you walk us through why you guys raised money and some advice around raising money, especially in kind of the manufacturing space?
Yeah, certainly. I think most companies, Series A is frequently the biggest hurdle.
Sure.
We did as you said, point out the Series B, but I can't underscore how important it is to take your time and have enough runway to find a great partner. We were very lucky in finding NEA, and as a result, their contributions to the company cannot be understated. We talked to a lot of firms, really kind of getting to the place where we found the right people and the right firm to lead things off. So I actually go back to Series A because I do feel like getting such a great partner was very important in getting to where we are now. So with regard to why, anyone that has an idea and is in a garage, has this the two directions that you can go. Do you go looking for investors, or do you try and grow it on revenue? So I think the highest level fundamental question is what somebody's working on fit the profile of a venture-backed business, and that's the first box to check. And there's a lot written about that. The second step would be, if it does fit the profile of a venture-backed business, then there's a lot to consider there. In the composites industry and in manufacturing, a lot, traditionally they've been not as venture-backed enterprises, and many of the manufacturing technologies come out of large corporate innovators. The venture community, and really a lot centered around 3D printing originally, but I think it's kind of evolved into a lot of other spaces. The venture community has started to embrace hardware and manufacturing technologies, and 3D printing created a lot of interest in that as well. So that shift, I think, is very important for people that like to make things, like to make physical things. And I think the level of maturity in the venture community is increasing quite a bit in the way the community thinks about the space. So getting back to your question of advice I have, we very early on had really great minimum viable products, and I think that the most important place to start, no matter kind of which track you take, is really learn about MVPs. There's a lot that's been written about that. A lot's been written about getting those in front of customers, getting customers to pay for those MVPs, giving you the conviction that you're on track of something good, and it gives you something that you can point to, for investors, that you have, legitimate, ideally world-class experts at top companies that have, significant commercial benefits associated with whatever you're showing to them that validate your claims. And when you have a batch of those application cases and customer stories, fundraising gets to be a lot easier, because it's not taking you at your word. It's taking third-party experts that know their space and know that they have a commercial benefit and wouldn't be wasting their time if there wasn't, endorsing that if you can get to whatever your milestones are that you're planning to hit with the venture money that you're seeking, then they're interested in taking a deeper look at it and possibly moving forward. And even better, if those individuals will act as references for you. That's always kind of a bit of a balancing act. But I think, these kind of general wisdom is really the path that we took, in working really closely with customers, really seeking to understand what they needed, really seeking to understand what commercial benefits we unlocked for them, and focusing on our capability development, meeting their needs.
Interesting. So how did you guys meet your first investors and convince your first customers to try out your technology?
So, I guess going even a step back from investors, reaching into your network, if you're looking for co-founders, seeking co-founders not just on technical merit, but also thinking about how you're rounding out the need for a founding team or a leadership team to have a good, deep network for technical expertise and guidance, as well as fundraising expertise and guidance. So, very early on, before we were seeking investment, we were very actively doing these things, and through actually a early customer, we were introduced to Carl Bass, the former CEO of Autodesk, who came on as really a great advisor, early angel investor, now a board member with the company, as well as others that have been very important. And one of those individuals was the husband of a friend, a coworker of my wife, who introduced me to a friend. It's one of those stories,
Right.
Who became such a valuable angel investor for us, not just because she was an angel investor, but she added all kinds of other value in helping us think about how to grow the business, as well as introducing us to a Forrest Basket at NEA, who she said, you've got to talk to these guys. And when it comes to finding a good investor, this has been said a million times, but getting an endorsement from somebody that they trust is so valuable. And this is really the kind of classic networking example where you have to really technically develop things, develop customers, but also really think about what is your investment space and how do you start networking in that investment space. It is absolutely one of those dig your well before you're thirsty type exercises that you need to be very proactive about that.
No, I think that's actually really good advice. Do you have any other advice for people that are looking to get into the manufacturing space?
Yeah, the manufacturing space is hard in some respects, is easy in others. So the trend of Kickstarters, Indiegogo, if you're manufacturing a thing, it's a little bit different than if you're developing a new manufacturing process. Right. So the world of manufacturing things has gotten really exciting with the venture community, Internet of Things, connected devices, Kickstarters. Really, all of those things are creating this kind of frenzy of activity that's just very excited about how quickly the physical world can start to iterate on itself and develop, great new ideas and new products. And the quick way in which you can get feedback for your minimum viable product through the crowd, and how you can show that to investors or bootstrap the company based on that money. There's a lot that's been said about all of those topics. If we look at developing a new manufacturing process, it is a little bit different because you are one step removed from the commercial transaction sometimes. So obviously, the closer you are to your revenue stream, the more control that you have over that, the easier it is to do a test, the easier it is to show investors that you've got customers that are willing to buy. So, this kind of precipitates, one of those core questions, are we going to sell machines to companies, or are we going to try and sell manufacturing services? The typical answer is, and I think what's kind of typically been more the case for more of the, at least in the 3D printing world, is to sell machines. And there's a good bit of history around those models, and that has its benefits and has its challenges. However, there are some like us that have really taken these manufacturing services to market. And while you are one step removed, because your customer has to sell product that you help them to design in order for you to realize revenue, when you tap into major brands that have such reliable and de-risked future cash flows, that in a different way de-risks your future cash flows if you can tap into those production opportunities. The biggest challenge, though, obviously, is these companies have incredibly high levels of scrutiny for any new manufacturing technology that they might entertain using. And it's really difficult to get buy-in from those teams that have to be so risk averse, and typically don't have an appetite for new manufacturing technologies that add risk. But the challenge and the danger a little bit is many of these companies will always try out and sample all of what's new and great to make sure they're not missing anything. But that's a far cry from actual production.
Interesting. No, I think that's actually really good advice, but we're kind of coming to the end of the show. So how about we close with mentioning where people can get more information about you guys and any other links you want to mention?
Yeah, ArrisComposites.com, ArrisComposites.com.
Perfect, Ethan. I really appreciate you taking the time out of your day to be on the show, and I look forward to keeping in touch with you, and have a good rest of your day.
Great. Thanks for great to speak with you.
Thank you. Okay. Bye.
Thanks for listening. Please visit our website at buildingthefutureshow.com to join the free community, sign up for our newsletter, or to sponsor the show. The music is done by Electric Mantra. You can check him out at electricmantra.com and keep building the future.